Hi student, I am Suvita from Erode Engineering College, Department of Mathematics, subject Matrix and Calculus, course code 23 Regulation 23 BS 101. Hi students, today we are going to see the topics Matrix and Calculus, Unit 1, Cayley-Hamilton Theorem. Every square matrix satisfy its own characteristic equation. This is the definition of Cayley-Hamilton Theorem. Every square matrix satisfy its own characteristic equation. Now let us see working rule of Cayley-Hamilton Theorem. Step 1, to find the characteristic equation. Next, step 2, by using Cayley-Hamilton theorem, substitute lambda equal to A and constant into lambda I. That means Cayley-Hamilton theorem we are using, substitute in lambda equal to A. Lambda in that place we have to substitute A and constant in that place lambda into I. Okay, then step 3, verify Cayley-Hamilton theorem. That means we have to verify, which means equal to 0. Now let us see, we will see in the some problems. Next, to find A inverse divide by A. So find, we want to A means we have to divide by A. Next, step 5, we find A4, A power 4, which means we have to find A4 means multiply by A. These are the working rules of the Cayley-Hamilton theorem. Now let us see problems of the Cayley-Hamilton theorem and characteristic equation. So first problem number 1, so that the matrix 1 minus 2 2 1 satisfies its own characteristic equation. Satisfies its own characteristic equations, which means equations matrix are given, we satisfy the characteristic equation. The question is like this, satisfies its own characteristic equation means, which means Cayley-Hamilton theorem. Now let's see, given matrix, given A equal to 1 minus 2 2 1. What is the step rule? Find the characteristic equation. What is the characteristic equation of 2 into 2 matrix? 2 into 2 matrix, which means determinant of A minus lambda I equal to 0. We have to use in this form, in this characteristic equation, which means 2 into 2 matrix means, suppose we have 3 into 3 matrix means we have to write lambda cube formula. Now let's see in minus 2 2 1 and lambda into, what is the I? Identity matrix 1 0 0 1. So you are substituting I value 1 0 0 1, determinant of 0. Next we have to minus, we have to inside the lambda, we take into lambda in inside 0 0 lambda equal to 0. So now we have to minus 1 minus lambda, minus 2 minus 0, next 2 minus 0, next 1 minus lambda equal to 0, determinant of equal to 0. Now we have to take determinant 1 minus lambda into 1 minus lambda is it 2 2 0 0. So 2 into minus 2 minus 2 into minus 2 4. So plus 4. 1 minus lambda plus 4 equal to 0. So we have to multiply 1 minus lambda, next lambda in multiply, minus lambda minus the minus plus lambda square plus 4 equal to 0. So we have to alternate lambda square, minus 2 lambda plus 1 plus 4 plus 5 equal to 0, plus 5 equal to 0. This is the one method of find 2 into 2 matrix the characteristic equation. We have to use in another method. Use another method. another method, lambda squared minus s1 lambda plus s2 equal to 0, because this is the 2 into 2 matrix. That's why we have to find a minus lambda I determinant of equal to 0. But we have, now we will have 3 into 3 matrix, means we use this characteristic equation. So this characteristic equation, lambda squared minus s1 plus s2 equal to s1 lambda plus s2 equal to, this is the characteristic equation. Characteristic equation formula, the characteristic equation. Now let's find s1. What is the s1? S1 is sum of the main diagonal elements. So what is the main diagonal elements? What is the A, matrix of A? 1 minus 2 2 1. So diagonal elements, in the two values are the diagonal elements. Sum 1 plus 1 equal to 2. So s1 equal to 2. s1 equal to 2. Next we have to find s2. What is the s2? s2 is determinant of A. What is the A? 1 minus 2 2 1. We have to take a determinant 1 into 2 into minus 2. So formula vara minus. So taking determinant 1 into 1 minus 2 into minus 2 equal to 1 plus 4 equal to 5. So s1 s2. So s2 is, we find s2 is 5. We have to substitute in characteristic equation lambda squared minus, what is the s1? 2 lambda. What is the s3? 5 equal to 0. Okay, this is the characteristic equation. We find the characteristic equation. Next we have to find using Cayley-Hamilton theorem. Using Cayley-Hamilton theorem. What is the rules of the using Cayley-Hamilton theorem? We have to put lambda equal to A and constant I, lambda I. So constant place we have to, for in this case we have to know that lambda space, we alternate lambda varies in this place, we have to substitute in lambda in this place A, and constant place we have to put in I. So what is the answer? A squared minus 2A plus 5I equal to 0. Using Cayley-Hamilton theorem. Next we verify the Cayley-Hamilton theorem. That's why it satisfies the characteristic equation. So what will we get? This equation equal to 0. We have to prove A squared minus 2A plus 5A equal to 0. That's why we have to find first A squared. We have to find, in this case, A equal to 1 minus 2 2 1. The given matrix we have to write. Next A squared. A squared means A into A. So A equal to 1 minus 2 2 1 matrix into 1 minus 2 2 into 1 matrix 2 1. Next we have to multiply. This means A into A. We have to multiply this row into column. First row into first column. First row into first column. Now let's see. 1 into 1 plus minus 2 into 2. Next 1 into minus 2 plus minus 2 into 1. Next row 2 into 1 plus 1 into 2. Next 2 into minus 2 plus 1 into 1. We have to multiply 1 minus 4 minus 2 minus 2. Next 2 into 2 plus 2 minus 4, 1 into 1 plus 1. We have to minus 3 minus 4, 4 minus 3. This is the a square. We find an a square value. A square equal to minus 3 minus 4, 4 minus 3. A square equal to, we know that a square minus 2a plus 5a equal to 0. We already know that a equal to 1 minus 2, 2, 1. Then I equal to 1, 0, 0, 1. And substitute this equation, we get in the 0 by using the Cayley-Hamilton theorem. We have to prove a square minus 2a plus 5a equal to 0. Now we substitute a square. Now we can substitute a and I. So a square minus 2a plus 5a equal to 0. Now let's see. What is the a square value? We already find minus 3 minus 4, 4 minus 3 minus 2 into a. What is the a? 1 minus 2, 2, 1. Next plus 5, what is the I? 1, 0, 0, 1. Next we have to prove inside multiplication, minus 2 minus 4, 4 minus 3, the same way like this. We have to multiply 2 into a matrix, plus we have to in minus 2 take minus 2 into minus 2 plus 4 minus 4 and 2 minus 2 we have to inside into minus 2 multiplication plus 5 0 0 5. Next we have to add minus 3 minus 2 this wise plus 5. Next minus 4 plus 4 0. Next 4 minus 4 plus 0. Next minus 3 plus 2 plus 5. This equation by 0. 5 minus 5 plus 5. So minus 4 plus 4. 4 minus 4. Minus 5 plus 5. So we have to get 0. All are 0. So this equations gives a square minus 2a plus 5i equal to 0. 5i equal to 0. This equation proves 0, 0, 0, 0. This verified. Cayley-Hamilton theorem. In this case, we have to satisfy its own characteristic equation. Suppose they ask these questions, we have to given the matrix using this methods, or otherwise using the characteristics method, this equation lambda squared minus s1 lambda plus s2. We have to find s1, s2, s3, and using we get the characteristic equation. We have to substitute in lambda equal to a and constant equal to I. So a squared minus 2a plus 5a equal to 0. Next we have to find a square. We know that a and I. Substitute, we get equations are 0. Matrix are 0. Matrix are 0 means verify the Cayley-Hamilton theorem. In this question, so that the matrix, they are giving the matrix satisfy its own characteristic equation. Asking the question, listen carefully, satisfies its own characteristic equation, which means we have to find a minus lambda equal to 0 characteristic equation. Otherwise, this is the 2 into 2 matrix method, or we can use in this method lambda squared, these characteristic equations. So find S1, S2 and substitute S1 and S1 values. And using Halley-Hamilton theorem means lambda values we alternate, lambda in this place we have to change in a and constant I. Next, a squared, we have to find a squared and a, substitute in a squared, a and I, we have to prove 0. This means 0, 0, 0. All equations, all values are added is 0. So verify the Halley-Hamilton theorem. Therefore, the given matrix satisfies, which is the question, its own characteristic equation. That's it. It's very simple. We have to find S1, S2 and substitute, and what is the lambda value, and lambda value in I and lambda equal to A. Then we have to prove 0, 0, 0. Next we have to see problem number 2. Verify Halley-Hamilton theorem. Find A inverse and A4. Given matrix A equal to 2 minus 1 2 minus 1 2 minus 1 1 minus 1 2. Now we have to solutions for Halley-Hamilton theorem verification. What is the rules? First we have to find in characteristic equation. To find the characteristic equation. So characteristic equation first. Next Halley-Hamilton theorem substitution, lambda equal to A, then verify. Then you will have to find A inverse and A4. Now let us see what is the first rule. Find characteristic equation. To find characteristic equation. Characteristic equation. So what is the characteristic equation? You know that lambda cube minus, why we are starting cube? Because this is the 3 into 3 matrix. So find characteristic equation lambda cube. Why we are starting cube? Because this is a 3 into 3 matrix. Lambda cube minus S1 lambda square plus S2 lambda minus S3 equal to 0, which is, this is the equation number 1. We gives equation number 1. Now let to find S1. S1, what is the S1? S1 is sum of the main diagonal element. Sum of the main diagonal element. Main diagonal elements. What is the diagonal elements? 2, 2, 2. These are the diagonal elements. These are the S2 is sum of the minors of the main diagonal elements. Which means we taking this matrix A. Next S2 means sum of the minors of the main diagonal elements, which means taking 2 first diagonal elements 2, omitting this column and row, except we have to write 2 minus 1 minus 1 2. Next we have to take second diagonal elements 2. We have to omit this row and column, balance remaining, right? 2 2 1 2 2 2 1 2. Next taking third diagonal element of 2. This row and column omitting, except we have to write 2 1 minus 1 2. 2 into 2 4, 1 into minus 1 into plus 1, the formula 11 minus 1 1. Then 2 into 2 4, 2 into 1 2, 1 into 2 1 2, formula minus 2, plus 2 into 2 4, minus 1 into minus 1 plus 1, in formula in minus 1. Next 4 minus 1 3, plus 4 minus 2 2, next 4 minus 1 3, then we have to add 3 plus 2 plus 3 equal to S8, to S2 equal to 8. Next S3 value, S3 equal to determinant of A. So what is the A? We know that the question. A, determinant of A, 2 minus 1, 2, minus 1, 2, minus 1, 1, minus 1, 2. Taking determinant, we have to take 2 means 2. We omitting this column and row, balance remaining this row, this column and row. 2 into 2, 4, 1 minus 1 into minus 1 plus 1, in formula minus 1, minus 1, in formula minus, already in minus 1, so plus 1, this row this column and row cancel, balance remaining minus 1 into 2, minus 2, 1 into minus 1 plus 1, plus taking this 2, which means this column and row omitting minus 1 into 1 plus 1, minus 1 into minus 1 plus 1, and 1 into 2 minus 2, formula 1 into 2 plus 2, formula minus 2. 2 into 3, 4 minus 1, 3 plus 1 into minus 1 plus 2 into minus 1. 6 minus 1 minus 2. So S3 equal to 3. S3 equal to 3. We find S1 equal to S1 equal to 8, S2 equal to S1 equal to 8, S2 equal to 8, S3 equal to 3. S1 equal to 6, S2 equal to 8, S3 equal to 3. S1, S2, S3. S1, S2, S3. So now we substitute in equation number 1, S1, S2, S3 values. Equation number 1 in a lambda cube minus S1 lambda square plus S2 lambda minus S3 equal to 0. Lambda cube. What is the S1? 6 lambda square. What is the X2? 8 lambda. What is X3? 3 equal to 0. This is the characteristic equation. Next we using the Cayley-Hamilton theorem by using working rule 2 இருக்குல்ல, using Cayley-Hamilton theorem, which means lambda equal to A and constant I, lambda I கொடுத்துறோம். இந்த இடத்துல I substitute பண்ணுறோம் I. அப்போ lambda equal to Aன்னு கொடுத்தோன்னா, lambda equal to A means A cube minus 6A square plus 8A minus 3 constant value I equal to 0. So next we have to verify Cayley-Hamilton theorem. Cayley-Hamilton verify means, which means equal to 0. We have to prove A cube minus 6A square plus 8A minus 3A equal to 0. Which means we have to prove 0. So first we have to decide A3. So verify Cayley-Hamilton theorem means, which means we have to prove 0. This substitute A3 we will substitute and A squared we will substitute and A we will substitute and I identity matrix will substitute. We get a 0 equal to 0. Left hand side equal to right hand side equal to 0. We have to prove. So we know that what is the A equal to 2 minus 1 2 minus 1 2 minus 1 1 minus 1 2. What is the A square? A squared equal to A into A. Here A cube equal to A squared into A. First we have to see A squared. We have to find A squared. So A into A. We have to find A into A. We know that the a minus 2 minus 1 2 minus 1 2 minus 1 2 minus 1 1 minus 1 2 a square 2 minus 1 2 minus 1 2 minus 1 1 minus 1 2. So a cross into a squared. A squared we will to see. Next class we will see in the next video. We will see how to calculate in matrix in a square. Now we have to solve. Next video I will teach in how to substitute in a matrix and a squared, how to find. Now let's see solve. First we take first row and column. Next 2 into 2 plus minus 1 into 1 plus next 2 into 1. Next first row and second column 2 into minus 1 plus minus 1 into 2 plus 2 into minus 1. Next first row into next column, third column 2 into 2 plus minus 1 into minus 1 2 into 2. In this method we have to solve very easy method in calculator. Next class video I will teach in how to calculate in calculator calci in matrix A square. Next second row and first column minus 1 into 2 plus 2 into minus 1 plus minus 1 into 1. Different sign, so we have to bracket, should bracket. Minus 1 into minus 1 plus 2 into 2 plus minus 1 into minus 1. Next minus 1 into 2 plus minus 1 into minus 1 plus minus 1 into 2. Next third row 1 into 2 plus minus 1 into minus 1 plus 2 into 1. Next this column, this row and second column 1 into minus 1 plus minus 1 into 2 plus 2 into minus 1. Next third row and third column 1 into 2 plus minus 1 into minus 1 plus 2 into 2. So next we have to solve. Now let's see. 2 into 2 4, 1 minus 1 into minus 1 plus 1, 2 into 1 plus 2. Next 2 into minus 1 minus 2, minus 1 into 2 minus 2, 2 into minus 1 minus 2. Next 2 into 2 4 plus 1 minus 1 into minus 1 plus 1, 2 into 2 4. 2 minus 1 into 2 minus 2, 2 into minus 1 minus 2, 1 into minus 1. Next 1 into minus 1 into minus 1 plus 1 plus 2 into 2 4 plus 1. Next minus 2 plus 1, sorry, plus 1, yes, plus 1. Next minus 2. Next 2 into minus 1 minus 2 minus 2. Next 2 plus 1 plus 2. Next minus 1. Next minus 2. Next 2 into 1 minus 2. Next 2 into 2 minus 1 into minus 1 plus 1 plus 4. So we have to add 4 plus 1 plus 2 plus 7 minus 6 9 minus 5 6 minus 6 ಇದು minus 2 minus 2 5 minus 5 7. So we have to find, we decide we have find out 8 squared equal to 7a 7 minus 6 9 this matrix. Next a cube equal to a into a square. What is the a? 2 minus 1 2 minus 1 2 minus 1 1 minus 1 2 a cube. 7 minus 6 9 minus 5 6 minus 6 5 minus 5 7. Next video I'm going to teach how to calculate in Calci. So direct value we have to apply 2 into minus 2 into 7 2 into 7 14 minus plus 5 5 into 2 10 plus 10. Next minus 12 minus 6 minus 10. Next 18 minus 1 into 6 minus 1 into 6 plus 6 2 into 7 plus 14. Next this row and this column. Minus 7 minus 10 minus 5 plus 6 plus 12 plus 5 minus 9 minus 12 minus 7. Next 1 into this column and this row. This row and this column, sorry. 1 7 plus 5 plus 10 5 into 2 10. Next minus 6 minus 6 minus 10. Next 9 plus 9 6 1 into minus 6. Next 2 into 7 14. So the answer is we get to solve. In this page we get to solve 14 plus 5 plus 10 14 plus 5 plus 10 29 minus 15, minus 12 minus 6 minus 10 minus 28. Next 18 plus 6 plus 14 38. Next minus 7 minus 10 minus 5 minus 22. Next 6 plus 12 plus 5 23. Next minus 5 minus 9 minus 12 minus 7 minus 28. Next 22. So this is the same answer 22. Is minus 22 plus 22. Minus 6 minus 6 minus 1 minus 22 29. So a cube is, so a cube value 29 minus 28 38 minus 28 23 minus 28 22 minus 22 29. So in this equation a cube minus quadratic equation 6a squared plus 8a minus 3a equal to 0. Left hand side equal to right hand side, which means we have to prove in 0. So a cube, we have to write a cube minus 22 minus 23 minus 28 22 minus 22 29. Next minus 6 into a squared. What we have to find a squared value? 7 minus 6 9. 7 minus 6 9 5 6 minus 6 5 minus 5 7 plus 8 into a. What is the a in this question? What is the a? 2 minus 1 2 minus 1 2 minus 1. Next 1 minus 1 2 minus 3. What is the I? 1 0 0 0 1 0 0 0 1 is equal to 0. So which means we have to multiply into 6 into 8 minus 3. Okay, 29 minus 28 38 minus 22 23 minus 28 22 minus 22 29. So directly we have to plus into minus 6 into inside minus 6 multiplication. 7 into 6 42 plus 36. 9 into 6 54 minus, this is a minus. Next, minus 6 into 5, because this is a minus, minus 30 minus 36 plus 36 minus 30 plus 30 minus 42. Directly inside multiplication 8 into 2 16 minus 8 16 minus 8 into 2 16 minus 8 minus 8 16. Directly 3 minus plus 3, oh, minus 3 inside 3 0 0 minus 3 0 0 0 minus 3 equal to 0. So we have to add directly 29 minus 42 plus 16 minus 3. Next, minus 28 plus 36 minus 8 plus 0. Next, 38 minus 54 plus 16 plus 0 equal to 0. Equal to 0. So next, minus 22 minus 30 minus 8 plus 0. 23 minus 36 plus 16 minus 3. Minus 28 plus 36 minus 8 plus 0. 22 minus 30 plus 8 plus 0. Next, minus 22 plus 30 minus 8 plus 0. Next, 29 minus 42 plus 16 minus 3. So we have to add 45 0. 36 minus 36 0. 54 plus 44 0. Next, minus, so this is plus 30, so minus 30 plus 30 0. This one 23 minus 26 minus 36 0. This is minus 36 plus 36 0. This is one minus 30 plus 30 0. Minus 30 plus 30 is minus 35 plus 42. 45 0. So verified. So the equations is added 0 0 0, verified. Next, we have to find A inverse. A inverse divide A. We will have to find A inverse means we have to divide in A. What is the equation? A3, we have A3 minus 6A square plus 8A minus 3A equal to 0. Now let us see divide A. A cube minus 6A square plus 8A on both sides. Minus 3A equal to 0. 0 divided by A, 0. So divided by A. Divided by A means A cube divided by A squared. 1A will cancel. Next, 6A squared by A, 1A cancel, 6A. Next, 8A by A plus A, 1A cancel. Next, minus 3 by A equal to 0. We have to write A squared minus 6A plus 8I. And I is, why we are substituting in here I? Constant lambda I. So you have to need working rules. So I equal to these equations will come. Equations this side 3 by A plus 3 by A. So we have we want only 1 by a. 1 by a, which means 3 will multiplication, this will gives divided. A squared minus 3a plus 8i divided by 3, which means a inverse. Okay, so we have to write 1 by 3 into a squared minus 6a plus 8i equal to a inverse. 1 by 3, a squared value already we have find 7 minus 6 9 minus 5 6 minus 6 5 minus 5 7. Next minus 6 into a. A value, what is the a? 2 1 1 2 minus 1 2 minus 1 2 minus 1. Next 1 minus 1 2 plus 8 into I. What is I? 1 0 0 0 0 1 0 0 0 1 equal to a inverse. So 1 by 3 whole common, 7 minus 6 3 minus 5 6 minus 6 5 minus 5 7. Next plus we have to multiply in 6 in minus 6 into multiply. So minus 6 into 2 minus 12 plus 6 minus 12 plus 6 minus 12 plus 6 minus 6 6 into minus 1 minus 6 into minus 1 plus 6. Next minus 12. Next inside 8 multiplication 8 8 0 0 0 8 0 0 0 8 equal to a inverse. So now we have to add this. I have to add 7 minus 12 plus 8. Next minus 6 plus 6 plus 0. 9 minus 12 plus 0. Inverse. Next minus 5 plus 6 plus 0. Next 6 minus 12 plus 8. Minus 6 plus 6 plus 0. Next 5 minus 6 plus 0. Minus 5 plus 6 plus 0. 7 minus 12 plus 8. So the answer is 6. For our convenience we have to write the same time. Next 9 minus 12 plus 0. So again we have to write these methods. A inverse. So now see 7 minus 8 15 15 3 15 minus 12. Next 0. Next 9 minus 12 minus 3. Minus 5 plus 1 plus 1. Next 6 minus 12 plus 8 15 minus 3. Sorry 8 plus 16 14 14 minus 2 2. Next 0. Next minus 1. Next plus 1. Next 15 plus minus 12 3 equal to a inverse, which means 3 division by 3. 1 by 3 matrix 3 division by 3 0 3 3 1 by 3 2 by 3 0 by 3 1 by 3 1 by 3. So now let's see, we have in confusion we have to 3 by 3 3 by 3 0 by 3 minus 3 by 3 1 by 3 2 by 3 0 by 3 minus 1 by 3 1 by 3 3 by 3 equal to a inverse. So the answer 3 by 3 1 0 by 3 0 by 3 in which calculator, or we have to know that 0.3 3 sorry 0 anything by 0 0. Next 3 by minus 3 minus 1 sorry 0. Next 1 by 3 1 by 3 0.3 33. So we have to use in calculator or 0.33. Next 2 by 3, 2, 3, 0.6, 18, 0.66. So 0.66. We use the calculator in easy method. Anything by 0, 0. This is 0. Next, minus 1 by 3, the same. Minus 1 by 3, minus 0.33. 1 by 3, 0.33. Next 3 by 3, 1. So the A inverse. So A inverse 1, 0, minus 1, 0.33, 0.66, 0, minus 0.33, 0.33, 1. This is the A inverse. Next we have to find A4 by using the formula, which means A4 we want to multiply by A on both sides. This is the formula. Okay, we have to put an equation number 1. So we equation number 1 la both side A multiply, we have to multiply. So A3 minus 6A square plus 8A minus 3A equal to 0. Multiply A means we get A4 minus 6A cube plus 8A square minus 3A. I will do the same 1 0 0 0. Next A4 we want only A4, so minus, so plus equation we get to this side, the sign will change. 6A cube minus 8A square plus 3A equal to 0. So therefore A cube value we already know. 6 into 29, 6 into 29, 6 into 29, 174. And we can also use in normal multiplication. Okay, so okay, we can use in the calci. 6 into 28 minus 28 minus 168. Next 38 into 6 into 38 228. Next 6 into 22 minus minus 132. Next 6 into 23 138. Next 28 already we find that 168. 22 already we find that 132. 23 already find that 132. 29 already find that 174. Minus 8 into 7. 8 into 7, 56. 48 plus 48. So we got to plus, we inside to minus into minus 8 into multiplications. So minus 56 minus 8 into 9, 72, minus 72, minus into minus plus 40, minus 48, plus 48, minus into minus plus 40. Next minus 40 plus 40, 56 minus 56. Again 7 irukku. Plus 3, very easy. 3 into 2 6, minus 3 or minus 1. So 6 minus 3, 6 minus 3, 3 into 1 3, minus 3, 3 into 2 6. So now we have to easily add 174 minus 56 plus 6 minus 168 plus 48 minus 3, 228 minus 72 plus 6. Minus 132 plus 40 minus 3. 138 minus the, you also know that the same row and same column add, minus 48 plus 6, next minus 168 plus 48 minus 3, 132 minus 40 plus 3, minus 132 plus 40 minus 3, 174 minus 56 plus 6. So the answer is 164, 174 plus 56. We have to use the calculator. 124 minus 123, 162 minus 95, 96 minus 123, 123, 95 minus 95, 124. So A4 is now using the Harley-Hamilton theorem. Once again we recall. First we have to find the characteristic equation. So S1, S2, S3 we have to find and substitute in S1, S2, S3 in equation number 1. Substitute in equation number 2, the equation number 2 we have to give. Using Harley-Hamilton theorem means verify. We have to check verify. So we have to change lambda equal to A. Then we have to verify means this is equal to 0. Left hand side equal to right hand side. So A equal to given the value and A squared equal to A cross into A. Next video I will teach in the calculator how to use in using matrix A into A square. Next we get the A squared value. Next A cube. A into A squared we count to A cube. So A cube equal to 0. We have substitute all the value. We get a 0. So verified we get 0. Next we have to find A inverse. A inverse means using the rules both side divide multiplication divide by A. So we get A inverse the answer. Next A inverse the answer, A inverse. Next you find A4 means they are using the step working rules divided by multiplication on both sides A. So we get A cube, A square. We will substitute these equations. We have to solve. In this equation, in this question, we have to solve only in derivations. But next video, I will teach in the using calculator how to matrix in A cross A, in A cross B. It's okay. Thank you, students.